Thank you, Kieran. So today I am talking about optimizing vitamin D food fortification strategies for older adults. And I suppose we've heard quite a lot about vitamin D up until this point. So I'm going to keep the background quite brief, other than to focus on this older adult cohort, which we're interested in the research that I'm going to present to you now. So the images I'm presenting here are actually taken from a large national study with over 5,000 older adults in it. This work was done by Dr. Eamon Laird and colleagues, and Eamon will actually be talking later on in the session. So I hope I do justice to his research. So the image that I'm presenting, essentially the colour guide indicates the proportion of the population that have vitamin D levels lower than the cutoff that defines sufficient. So what's really concerning, I suppose, is that for almost half the year, about half of the Irish population of older adults is not at the level that we would like them to be at. This is a concern because we also know that low vitamin D status is linked to frailty in older adults, as well as bone health and therefore osteoporosis. And there's evidence for a role in other chronic diseases like diabetes, cardiovascular disease, and even cancer. So low vitamin D status, particularly in an older adult cohort, is a major public health concern. So how can we improve vitamin D status? What I'm presenting today is actually a series of work that we've done here in UCD, and actually Stephen has already mentioned some aspects of the study that we'll touch on again later in the presentation, but it's all part of the NutriPlus study. And essentially, we're looking at how we can improve vitamin D status for older adults. So in an ideal world, we might try to row ourselves further south so that we can increase sun exposure and then increase vitamin D synthesis. But failing that, then our two options are, well, number one, increase the availability of vitamin D in foods. And again, Stephen was talking a little bit about that. And number two then is to increase intakes by improving how much we can absorb. And again, Stephen was touching on some of that. And so I suppose we're going to look at, or I'm going to look at the human side of Stephen's work. All right. There we go. So in the first study, oh, 1 second, sorry. In the first study, we're looking at ways that we can increase availability through food fortification. So just to mention that the work that I'm presenting today is all Dr. Aisling McCourt's PhD research. So Aisling recently submitted and defended her thesis. So I'm just presenting a summary of what she has done. So already we have foods in Ireland that are voluntarily fortified with vitamin D. But some countries have policies where mandatory fortification of certain foods. So essentially, we wanted to look at this and model the effect of introducing a mandatory vitamin D fortification policy in Ireland for older adults in particular. So in this analysis, we took data from the last National Nutrition Survey. So this data was collected between 2010 and 2012, so it's a little bit old. And we focused specifically on adults over the age of 50 that were part of this cohort. So as a first step, we updated the composition of foods to reflect the current vitamin D concentrations in foods, given the fact that the data was collected about 10 years ago. So we did this using food packaging data, or where packaging data wasn't available, we used the COVID food database. And we also created a new variable to categorize foods into added or natural vitamin D foods. So we looked at habitual intakes and categorized people according to several levels of intake. So in this cohort, about 5% consumed more than 20 micrograms, which is the recommendation from the IOM for older adults. About 10% met the EFSA recommendation, which is 15 micrograms, which is now the new FSAI recommendation as well. And about 20% were consuming greater than 10 micrograms. And then the majority, so 80%, were consuming less than 10 micrograms. So next, we wanted to look and see, well, what were the foods that were we could fortify essentially. So we looked at natural and added sources of vitamin D in the diet, and we identified the most frequently consumed foods that had some added vitamin D in them were milk and bread. So we chose to take these forward for our data modeling scenarios. And what you can see here on the slide is I've presented the outcomes of the 5 modeling scenarios for milk and for bread, and we also included a supplement group. And then we looked at a combination of milk and bread. I'll just briefly mention what these scenarios are, but I'll focus more on those that were kind of coming out as the most effective. So in the first scenario for the milk and bread modeling, we removed intakes and added a single daily portion of the fortified milk or bread. In scenario 2, we added a single daily portion of fortified milk for everybody in the cohort. In scenario 3, we substituted current intakes with the proposed fortification level. In scenario 4, we substituted current intakes of the consumers, and then we gave a 5 microgram supplement for non-consumers. And then in scenario 5, we substitute current intakes at the proposed fortification level and added a 10 microgram supplement for non-consumers, just to look at the impact that would have. And then in our supplement scenarios, we had add a 5 microgram supplement for non-consumers only, add a 10 microgram supplement for non-consumers only, add a 5 microgram supplement for everybody, or add a 10 microgram supplement for everybody. And then the 5th bar on that supplement scenario is actually the milk and bread combined. I just wanted to add it in so that I could show you the data there. So in terms of the kind of most beneficial outcomes, if we added 2 slices of bread to habitual diets, it resulted in the biggest increase in our mean vitamin D intakes. So that would be adding 2 slices of fortified bread to everybody's diet would result in a mean vitamin D intake of 16.4 micrograms. However, this means adding to energy intake as well, which we wouldn't want to do. So if you modified that and only fortified bread for the people already consuming bread, then that figure would actually be 12.8 micrograms. We did the same with milk, and as you can see, intakes would increase to 10.5 micrograms if we added a glass of fortified milk. But if we combined the 2 approaches, we saw the best effects. So that's looking at scenario 5 on the bottom of the graph. So fortifying current consumptions of bread and milk would result in intakes as high as 15.2 micrograms. So essentially, what we're showing here is that fortifying commonly consumed foods is effective, and that combining a number of foods, so in this case we were looking at 2 foods combined, was better than just fortifying one food type. At this point, I should also mention that in this analysis, no participant exceeded the tolerable upper level of 100 micrograms. So based on modeled data, at least, this level of vitamin D fortification is safe in this cohort. Okay, so next, moving on from looking at the availability of vitamin D from food sources, the next option is to look at increasing vitamin D absorption. So this is focusing much more on the work that Stephen has already described. So can we improve how much vitamin D we absorb from foods? Well, there's actually very little known about vitamin D absorption from a human perspective. There's only a handful of studies that have measured the postprandial response to vitamin D. So, but what we do know is that vitamin D is incorporated into fat micelles, as Stephen described. And so I suppose because Stephen described that there, I'm just going to jump straight ahead and look at what we were seeing then in our human studies. So in the first part of this study, we recruited healthy adults and brought them into UCD for 4 visits. And during these visits, they had to drink a dairy-based drink that contained vitamin D, but with slight variations in the lipid component of it. So in the first one, it was the one that Stephen described, the preformed micelles. We added these to the dairy drink. The second, we looked at an oil that had long-chain fatty acids in it, and we used olive oil. We also used a long-chain fatty acid oil, which was fish oil. And then we had a vitamin D drink that had a no-fat component to it. So this slide presents the kind of key results from that postprandial study work. And as we look at the timeline on the x-axis of this graph, I just want to mention the kind of the sequence of the visit. So our participants arrived fasted in the morning. We took a baseline sample. The participants then drank the relevant study drink, and then that was followed by a low-fat breakfast with no vitamin D in it. And then we took blood samples at 2, 4, 6, and 8 hours. And the participants got, again, a light lunch after the 4-hour blood sample was taken. So as you can see from the graph, we split our group into those that were classified as sufficient or insufficient vitamin D status, because we could see that the vitamin D status at baseline had a very big impact on their response to the drink. So in the first group, so focusing on the top of the graph, in the sufficient participants, we reported no change in 25-hydroxy vitamin D concentrations over the 8-hour time frame. And this was specific to that sufficient group. However, we did see some changes in the group that were insufficient at baseline, so that you can see these on the bottom of this graph. So in particular, and I've highlighted this in red, we can see a significant change in 25-hydroxy vitamin D concentrations following the olive oil fortified dairy drink. So you can see that in the red line on the bottom of this figure. So I know looking at this, you're probably thinking, hang on a second, the preformed micelles, which is the one where you see the peak at the end of that graph, shows higher concentrations, but this change isn't actually significant. There was huge variation in the change in 25-hydroxy vitamin D after all drinks, but particularly after the micelle drink. So what we're concluding is that we can report a significantly higher increase when the 20 micrograms of vitamin D is consumed with a dairy drink that uses an olive oil as the lipid component. But there is a lot more to understand about what's happening at the level of the gut, or potentially post-absorption in the liver hydroxylation step, seen as what we're looking at here is the 25-hydroxy vitamin D rather than the cholecalciferol. Okay, so from there, we move to the second part of looking at absorption. And in this study, we were looking at absorption over a longer period of time, and we had a bigger cohort of participants as well. So in this study, we changed things around a little bit. We dropped the micelle group and we added a coconut oil-based group. So there was 3 groups consuming a kind of dairy drink. One had 20 micrograms of vitamin D added with olive oil as the lipid component. One had 20 micrograms of vitamin D with coconut oil as the lipid component. There was a placebo drink with no vitamin D in it. And we also added a pill, the kind of traditional pill type supplement, which was 20 micrograms of vitamin D as well. And so we recruited older adults to this study and we measured vitamin D status before and after. So just to kind of summarize the methods here, we had in or around 15, 16, 17 participants per group. Actually, this study was also impacted, unfortunately, by COVID-19 restrictions. Luckily, we were coming to the end of the intervention when the first lockdown came. So we just lost a couple of participants from each group. We had aimed for 20 participants per group here. So our participants consumed either their drink or their vitamin D pill daily for 4 weeks. And we measured diet, we measured anthropometrics, we measured 25-hydroxy vitamin D concentrations, some aspects of metabolic health, so the traditional biomarkers like glucose, insulin, cholesterol, and so on. And we also measured metabolomic profiles. But for the purpose of this presentation, I'm really focusing on some aspects of diet, some of the anthropometrics, and also then the change in 25-hydroxy vitamin D. So just to start looking at some of the baseline data, so this doesn't involve any of the post samples at all. If we focus on the pie chart on the right-hand side, firstly, you can see that about 69% of the cohort were classified as vitamin D sufficient at baseline. So this is actually quite high relative to kind of national data. 22% were insufficient, so they had between 30 and 50 nanomoles of 25-hydroxy vitamin D, and then about 9% were classified as clinically deficient, with 25-hydroxy vitamin D less than 30 nanomoles per litre. If you look at the dietary intake data, so that's the bar graph on the left of the pie, only one person was consuming more than the recommendation, which is the 15 micrograms. 9% were consuming between 10 and 15 micrograms, and 28% were between 5 and 10 micrograms. And then the majority, again, 62%, were less than 5 micrograms. If we go left again at this, we see a table. We also used regression analysis. We're not showing the regression analysis here. I've just shown a table that actually is a chi-squared analysis comparing groups. But essentially, there's two traits that I wanted to pick out here. So firstly, waist circumference, and then the second one being vitamin D intakes. And we saw a relationship with both, not surprisingly, based on what we know from the literature. Higher intakes of vitamin D are associated with a better vitamin D status. A higher waist circumference was associated with a lower vitamin D status. So that's just to give you a sense of the cohort and some of the factors that were contributing to vitamin D status at baseline prior to supplementation. Okay, so the kind of main outcomes that we're interested in is looking at that time times treatment effect with or across our different supplement groups. And again, we see huge differences in the sufficient and insufficient participants. So we have split by baseline vitamin D status when we were looking at that change over the 4 weeks. Before I compare the results of our two groups, I want to highlight the different y-axis scales. So although it looks like the sufficient group are increasing at a similarly high rate to the insufficient group, the scale is actually quite different. You're seeing about a 30 nanomole increase in those on active treatment if they were insufficient, whereas if you look at the top of the graph and you look at the sufficient group, they're actually only increasing by kind of 6 or 7 nanomoles per litre over the 4 weeks. Anyway, as you can see by the red lines, all of the vitamin D supplemented participants who were vitamin D insufficient at baseline significantly increased their vitamin D status over the 4 weeks. So in this, no one treatment was better than the other. They all improved. And from a stats perspective, there was a significant time treatment effect and a significant effect of time overall for the insufficient cohort. In comparison, we see a time times treatment effect in the sufficient group, but no overall effect of time. When you dig into the time times treatment effect, you see that the change in 25-hydroxyvitamin D levels in the coconut oil supplemented group and the kind of regular pill type supplement group was more than in the olive oil dairy drink group or the placebo, obviously. It's also worth noting here that 94% of the participants who were consuming a vitamin D fortified dairy drink or supplement were classified as sufficient after the study. So overall, taking 20 micrograms of vitamin D per day, whether it be in a pill or in a drink, is effective at moving people from insufficient status to sufficient status. The 3 participants within the group that didn't reach sufficient levels were still borderline. They were in or around 45 nanomoles per litre, and all of them improved by about 30 nanomoles per litre. So I think that's a really important finding to note from this research as well. Okay, so this is my last slide, and I just want to kind of summarize some of the key messages and kind of point to what this might mean and what's next from a research perspective, at least. So firstly, based on our data modeling, it seems clear that we can reach vitamin D intake recommendations with food fortification, and fortifying a combination of foods will be more effective. And I suppose it's important to mention that these results were particularly for an older adult cohort, so adults older than 50 is what we selected out from the NAMS cohort. So secondly, then it seems as though there is scope to manipulate absorption by changing the lipid component of foods. However, there's still a lot of unknowns with respect to vitamin D absorption, and there's high inter-individual variation. We still don't really have a good picture of vitamin D absorption, essentially, but there is some potential to look at this in another way. I think there's 1 or 2 papers recently reporting cholecalciferol concentrations as a marker of immediate absorption, but just very little published as of yet. But I think this is something that we need to consider to just get that better understanding of absorption kind of in the kind of immediate hours after consuming vitamin D. And then Lastly, from our intervention study, it's clear that fortified foods are as effective as your traditional pill type supplement and thus offer significant scope to increase vitamin D status, particularly when looking at older adults as a cohort, who for one might be less likely to introduce new foods to their diets. So, I mean, if you're developing an innovative food like a bar or a particular yogurt drink, maybe older adults are not the cohort that are going to suddenly change their diet, but if it's introduced at the kind of at levels where they're in foods that they're already consuming, it might be an attractive alternative. Also for those in later stages of life when swallowing might be an issue, this type of fortification of liquids or soft fortified foods might be a better alternative to a pill or capsule form. So all that combined, I think we can conclude by saying that there's strong evidence for mandatory fortification. And even within that, I think there's scope for personalization. So on that note, I just want to say some thank yous. So firstly, just to acknowledge that I'm presenting Aisling McCourt's PhD research here. So thank you to Aisling for all her hard work, and obviously to Stephen as well, who has presented already. And then to the wider group, so Professor Dolores O'Riordan, who is the lead on this, Dr. Graham O'Neill, and also Dr. Emma Feeney, Michelle Kearns, and Emma Regan, who are also involved in the study. So thank you.